Welcome back to our series on the cell-based model of hemostasis. This is part 3 of 4, where we will discuss propagation, the production of large amounts of thrombin in order to make an effective fibrin clot, and we will discuss the mechanism of the direct thrombin inhibitors. We begin where we left off in part 2. The platelet has been activated, and factors 11A, 8A, and 5A are stabilized on the surface of the activated platelet. In propagation, factor 9A in the vascular milieu, or factor 9, is activated by factor 11. Factor 9A then forms the complex on the platelet surface known as tenase. Just as you might think from the name, tenase activates factor 10 to factor 10A. What's important about propagation is this occurs locally on the platelet surface, giving very little time for free-floating factor 10 to be degraded, creating the enzyme known as prothrombinase. Prothrombinase is a highly effective enzyme complex, especially when it's stabilized on the enzyme surface, taking factor 2 and producing large amounts of factor 2A, otherwise known as thrombin. Thrombin then, most importantly, converts fibrinogen, also known as factor 1, to fibrin. And fibrin begins to form along with more platelets to begin to form a fibrin clot. What's also important, as these fibrin mesh begins to form, it also traps numerous factors critical to clot regulation. In fact, factor 2A, or thrombin, is trapped within this mesh. In addition, plasminogen is trapped. And something very important to all cardiology pharmacists is TPA, or tissue plasminogen activator, is trapped. I like to think about this trapping as the prelude to termination. Thrombin also activates factor 13 to factor 13A. What's important about factor 13A is that it actually creates covalent cross-links between monomers of fibrin, stabilizing this clot formation. I sort of like to think about this step as the duct tape. The more cross-links you create with activation of factor 13, the more stable the clot is and the longer it takes to break down. But however, eventually termination will occur, and we will specifically discuss termination in the next video. Thrombin production here in propagation is critical to the regulation of clot formation. Thus, direct thrombin inhibitors are potent anticoagulants. In acute coronary syndromes, we use the agent known as bivalirudin. Bivalirudin is a direct thrombin inhibitor that binds reversibly to thrombin at the active site. Notably, bivalirudin acts not only here at freely circulating thrombin, but also here at clot-bound thrombin. In the next and final video in this series, we will discuss physiologic termination and the final drug categories that are important to the understanding of acute coronary syndrome. Hope you'll join us. Thanks.